Hi students, in today's class I would like to explain about dynamic CMOS logic. The dynamic CMOS logic. So in the last class already we seen one of the type of alternative gate circuit is pseudo NMOS logic. So the main advantage of these alternative gate circuits is so it uses less number of transistors as compared conventional CMOS logic. So here the shown diagram represents the dynamic CMOS logic. So here in this diagram, so it may have a pre-charge transistor and evolution transistor. So these are the take active part to produce the functionality, the logic functionality of the design. So here a dynamic CMOS logic uses charge storage and clocking properties of MOS transistors to implement logic operations. So whatever in this shown diagram, so we're having the pull-up device and the pull-down devices. So the pull-up device is called as a pre-charge transistor and the pull-down device is called as a evolution transistor. So whatever the logic we have to implement it, so that will be implemented by using NMOS transistors. So at the place of whatever the Vin represent in the shown diagram, that is whatever here we have NMOS logic, at this place we have to implement the NMOS by using the NMOS transistors. We have to implement the logic functionality, whatever the logic we have to required. Clear? So here so that will uses the charge storage and the clocking properties of the MOS transistors. So whatever we have to implementing, so the logic functionality, so that uses both the clock and the NMOS logic. So here the clock, whatever this clock signal, so it drives an NMOS evolution transistor and the PMOS pre-charge transistor. So first case 1, so coming to the operation, so whatever we are the clock signal, so pi is equal to 0, at the time the circuit is in the pre-charge transistor. So because whenever we are applying the 0 input to the p-type transistor, so the transistor will be on and the n-type transistor will be off. So based on that reason, so the circuit is in pre-charge phase with the PMOS device is on and the evolution NMOS device is off. So this establishes a conducting path between the VDD and the output, so that will allowing the Cout to charge to a voltage VDD. So whatever in this mode, if the pi is equal to 0, the p-type transistor will be in on condition and the n-type transistor will be in off condition. So whatever the path will establish from VDD to Cout, so we get the Vout is equal to VDD. And the second case, when clock is equal to, when clock pi is equal to 1, so at the time the circuit is in evolution phase with the PMOS device is off and the NMOS device is on, the logic block acts like as a closed switch that can discharge through logic array and the evolution transistor, that means through evolution transistor, Cout is equal to discharges through whatever the logic we are having through an evolution transistor. So at the time the Vout is equal to 0. So by using this circuit, so we have to implement the CMOS technology, but so compared with conventional CMOS transistor, so it will gives less number of transistor and low power consumption. So those are the main advantages of alternating CMOS circuits. So here we will see one of the example, so how we will get the result from the dynamic CMOS logic. So here the problem is, so one of the example is implement 3 input NOR gate by using dynamic CMOS logic. So here we have to do one problem with dynamic CMOS logic. Implement 3 input and NOR gate by using dynamic CMOS logic. So for that problem is the design is, so already we know that the NOR functionality is y is equal to a plus b plus c whole bar, a plus b plus c whole bar for a 3 input NOR gate. So this will be implemented by using the dynamic CMOS logic. So the answer for that question is, so the design is, so here whatever the diagram will shown in this diagram, so that is, so in the upper mode we are having the pre-charge transistor, and in the below we are having evaluation mode transistor. So here coming to for our operation, so the three, here we are having 3 variables. In this expression we are having 3 variables, so we require 3 NMOS transistor, and the logic is, so if the R function, we have to perform the R function, so the NMOS transistor should be in parallel. So because that will be the condition for NMOS logic. So if you want to perform any R function in NMOS transistor, so that the connection will be connected as a parallel. So that's why the 3 transistors will be connected in ABC mode. So whenever, so if that so whenever we will observe the truth table, so we get if the pi is equal to 0, so pi is equal to 0, so at the time so the p type transistor will be on, and the n type transistor is in off condition, so that output will be high. So based on whatever the condition is, so if the A, B, C are 0, 0, so then we will get high. So whenever the condition will be any one of the input is 1, so at the time that will be the flow will be the whatever the conducting path will creates a path from VDD to ground, and then the C will be discharged. So we will get the 3 input NOR gate by using this design. So the main difference between conventional and this one is dynamic CMOS. This dynamic CMOS is, so here we required less number of transistors compared with conventional, and based on that we will, so that the circuit will consume low power consumption, and the capacitance also, so that require very low capacitance, so we will fulfill our requirement. So another topic is, so another type of alternative gate circuit is CMOS domino logic. So it is also similar to the dynamic logic, but there will be a difference between dynamic and the domino is at the output of dynamic CMOS logic. So we having a CMOS inverter at the output. So that is the main difference between dynamic and the domino CMOS logic. So here the domino CMOS logic is a slightly modified version of the dynamic CMOS logic circuit. The addition of the inverter solves the problem of cascading of dynamic CMOS logic circuit. So here by using this circuit we are having some advantages. Those are nothing but small area compared to conventional CMOS logic. Parasitic capacitances are smaller, so that higher operating speeds are possible, and non-inverting structures are possible because of the presence of inverting buffer. So these advantages we will get by using the CMOS domino logic. So by using CMOS domino logic, we will implement one of the logic functionality. Those are nothing that example is implement a CMOS inverter by using domino CMOS logic. Implement CMOS inverter by using domino CMOS logic, and for that one the resultant is so here we have to implement a inverter functionality. That is, already we know that the inverter functionality is y is equal to a bar, so here we have one variable, so that's why we require one NMOS transistor. So in between pre-charge and the evaluation mode, so we having the NMOS logic, so here we have to place a NMOS transistor, so from that we get the output. So whenever the pi is equal to 0, so at the time p type transistor is on and the n type transistor is on. So if the a input is 0, so that will the NMOS transistors is also off, so there is no conducting path from the VDD to ground. So at the time so whenever the p type transistor is on, then it will gives the one logic, that is VDD voltage across the input. So from based on by using this inverter, so we get the inverting functional. That means if the input is 1, so we get the 0, or if the input is 0 and we get 1. So based on that, so again if the in case 2, if the clock signal is changes, if the clock signal pi is equal changes to next case, that 1, so at the time NMOS transistor is high, then that will creates a conducting path from VDD to ground. So then we get the output, that is input to the inverter is 0, so then output is 1. So based on this operation, so we implemented the inverting functionality by using the CMOS domino logic, and the advantages for this logic is so the non-inverting structures, whatever the non-inverting structures are possible, so because of the presence of inverting buffer. So at the output we are having the inverting functionality. So based on that we can easily implement the non-inverting functionality rather than the inverting cases. Thank you.